Okay, so in our today's class we are going to discuss about fluid bearing. So before knowing about the fluid bearing, we want to know one of the important part in that fluid bearing is Sommerfeld number. So in the design of fluid bearing, the Sommerfeld number is a dimensionless quantity, very important. It doesn't have any dimension which means it doesn't have any unit. Dimensionless quantity used extensively in hydrodynamic lubrication. So we'll be seeing in the next slide what is mean by hydrodynamic and what is mean by hydrostatic lubrication. Okay, the Sommerfeld number is very important in lubrication analysis because it contains all the variables normally specified by the designer. So normally or designer என்னென்ன variablesலாம் include பண்ணணுமோ அது எல்லாமே எங்க இருக்கும் அப்படின்னா it will be available in the Sommerfeld number. Let us go back to our data book. So if I go back to our data book and if you see here, page number 7.34. In page number 7.34 for hydrodynamic journal bearings, you can see the first formula available is a Sommerfeld number. S is the notation to represent the Sommerfeld number, which is nothing but Z dash N dash divided by P into D by C. So Z is nothing but the coefficient value. Okay, N is nothing but speed in a revolution per second. P is nothing but the pressure, D is nothing but the diameter, C is nothing but the diametrical clearance. Okay, so this is the definition about a Sommerfeld number. Now let us see about what is the difference between hydrodynamic and hydrostatic bearings. So before knowing about hydrodynamic and hydrostatic bearings, we will be seeing about the fluid bearings. Fluid bearings அப்படின்னா என்ன அப்படின்னு பார்த்தீங்கன்னா the bearing where artificial cooling is done. You have that in your mind. Okay, so hydrostatic bearings are generally extremely pressurized fluid bearings where the fluid is usually oil, water or air and the pressurization is done by a pump. அப்போ hydrostatic bearing அப்படின்னா என்னன்னா the fluid is not always present along with the bearing. It is being supplied by a pump where the particular fluid may be oil or water or air. Now what is the difference between a hydrodynamic bearing? So hydrodynamic bearing rely on the high speed on the journal, okay, to pressurize the fluid in a wedge up between the faces. அப்பனா என்ன அர்த்தம் அப்படின்னா the hydrodynamic bearing is a bearing in which the bearing itself is always available inside a fluid. Okay, so the part of the shaft resting on the fluid, that is very important. You can see here it is very clearly given, the part of the shaft resting on the fluid. So it is depending upon the phases. For example, between the journal and the rotating part, it is basically depending upon the lubrication. So this is very important. Sommerfeld number, hydrodynamic bearing or a hydrostatic bearing. But basically we for heavy load we use only hydrodynamic bearing. So this is a small introduction about what is a fluid bearing, what is a Sommerfeld number and what is a hydrostatic and hydrodynamic bearing. Okay, so now let us go directly into a problem. Okay, so since I want to make it very clear, I will go directly into the problem for a hydrodynamic bearing. There is no difference in sliding contact bearing and hydrodynamic bearing. The only thing is it is a fluid bearing. Either a fluid artificial cooling will be a continuous manner by hydrostatic, or otherwise the particular bearing will be placed inside a completely fluid in order to reduce the temperature. Okay, so let me go into the problem directly. The following data is given for a 360-degree hydrodynamic bearing, radial load, so W கொடுத்திருக்காங்க, journal speed N கொடுத்திருக்காங்க, so journal diameter capital D கொடுத்திருக்காங்க, journal length L கொடுத்திருக்காங்க. So இதை வச்சு நான் என்ன கண்டுபிடிக்க முடியும் அப்படின்னா I can find out what is L by D. So I can write directly L by D is equal to 1. Okay, so if it is not given in the problem, with the help of the journal diameter and the bearing length, I can write out L by D is equal to 1. Okay, so then they are given the unit bearing pressure. Even though if they have not given this unit pressure, for example, if the pressure is not given in this particular problem, I already told you how to find out the unit pressure, which is nothing but, so P is equal to, so there are some reasons why I am telling this, because if these data are not given, you should be able to identify it. So P is equal to W into L into D. So all these three data are available. I know the W value, I know the L value and I know the D value. If this particular unit bearing pressure is not given, this is the way you have to identify. because I know the load value, I know the length value, and I know the D value. The next thing is a diametrical clearance, where which is nothing but C. The third thing is viscosity Z. You be very clear here. It is given as 25 centipoise. So the unit conversion is very important. To know about the unit conversion, Mr. Venkatesh sir has been given a very clear note. See here. I hope it is visible to you. 1 centipoise is equal to 10 to the power minus 3 Newton second per meter square. Okay, I repeat again, 1 centipoise is equal to 10 to the power minus 3 Newton second per meter square. See here the viscosity is given as 25 centipoise. So it can be written as 0.02525 Newton second per meter square. Newton second per meter square, which is nothing but a viscosity Z value. So everything is given very clear. So you be very clear with this unit conversion. It is very important. Okay, if this part is wrong, the entire problem will be wrong, because here the data book what we use will be using the units in a certain uniform manner. Okay, assuming the total heat generation in the bearing is carried by the total oil flow in the bearing. So here it is very clearly given, definitely I need a oil flow. So definitely I need a oil flow here. So calculate number 1 coefficient of friction, which is nothing but mu. So power lost in the friction, yes. Minimum oil film thickness, which is nothing but a H naught. So minimum oil film thickness, which is nothing but H naught. Flow requirement in liter per minute. Flow requirement in liter per minute, which is nothing but Q. So temperature rise, either it may be del T or T naught value. So either it may be del T. Okay. So when I read out the problem, I have been given what are the given data. So W is equal to 3.2 kilonewton, N is equal to 1490 rpm, D is equal to 50 mm, L is equal to 50 mm. Unit bearing pressure is equal to 1. P. Pressure P is equal to 1.3 megapascal. C is equal to 0.05 mm, Z is equal to 25 centipoise. These are the given data. As I told that what are the things to be identified, I have been given over here. Okay. So now let us start of a problem, and let us try to find out what has to be found out. Okay. So to start with, let me go to a data book, and from data book page number 7.34. Tell me what is the formula for S. So tell me what is the formula for S. So you can go here and you can identify Sommerfeld number S is equal to Z dash N dash into D by C square divided by P. So this is the formula. So from data book I am writing the formula. So Z N divided by P D by C the whole square. So the reason why they have given here a small number is the small n is nothing but the revolution per minute should be in revolution per second, or the speed should be in revolution per second. That is very important. Okay, now I know what is the Z value. So Z value is nothing but 0.025, and the revolution per second is nothing but I can write it here. The speed value is given for me is 1490 divided by 60, and the value of pressure is given as 1.3 megapascal, which I have to convert into Newton per meter square. So 1.3 into 10 to the 6. I hope you understood the unit conversion. It is given in megapascal. I need it in Newton per meter square. Okay, so into what is the D value? 50, and what is the C value? 0.05 the whole square. Okay, so I hope you are using your calculators and you are calculating it, and if I identify it, the value of S would be 0.477. As I told in my explanation, it is a dimensionless value. It doesn't have any unit. So I hope you understood. I have simply solved the given data available in my given data, and I have it done. So what I have done differently is the RPM has been converted into revolution per second. revolution per minute is been converted into revolution per second by dividing it by 60, and similarly the pressure given in 1.3 megapascal is been converted into 1.3 into 10 to the power 6 Newton per meter square. So with which I have been find out our Sommerfeld number. Okay, now we have to go back to our data book. Here the data book usage is very high. Okay, so now let us go back to our data book. The L by D ratio, what we know, the L by D ratio what we know is 1. Okay, see here I'm in page number 7.36. You kindly write down it. So from data book page number 7.36, for L by D is equal to 1. I repeat again, for L by D is equal to 1 and S is equal to, what is the S value is 0.477. You look in this particular column. You look in this particular column whether it is available for 0.477. When I come over here, see you have 0.264 and then you have 0.631. Can anyone tell me what should I do to identify the value in between these two? Can anyone tell me? I am having 0.264 and I am having 0.631, but my value is in between these two. What should I do? Yes?
Sir.
Yes, what is the method? You have studied in your mathematics. You have done in your thermodynamics. Yes, very good. Yaar. What is that?
Interpolation.
Yes, very good. Interpolation is the method. If any value is in between these two, I have to do the interpolation and I have to find out the value. So I hope you know about that interpolation. எனக்கு இதில் என்னென்ன வேல்யூ வேணும் அப்படின்னு சொல்லிடுறேன். I need 2h0 by c. See here. So 2h0 by c is between 0.6 and 0.8. Okay, and I need mu d by c. The mu d by c is between 5.79 and 12.8. And I need the other thing is 4q divided by dcnl, which is between 3.99, which is between 3.99 and 3.59. So I repeat again, sir, it is very, very important. So I have identified the Sommerfeld number. From Sommerfeld number, I came to page number 7.36. For L by D ratio is equal to 1. I know the value of Sommerfeld number is between 0.264 and 0.361. I have to identify the value of 2h0 by c, mu d by c, 4q divided by dc n into L. I need to identify these values. So for which I need to identify the interpolation. So I have made interpolation already. So from data book page number 7.36, from data book page number 7.36, for S is equal to 0.477 and L by D is equal to 1 and L by D is equal to 1 by interpolating, very, very important, by interpolation. I hope you know the interpolation can be done in your calculator. So by interpolation, I will tell you the values. So after interpolation, mu d by c is equal to 9.87. Okay, and similarly 4q divided by d c n dash L is equal to 3.75. So why they have been using n dash in our data book is nothing but it is a revolution per second. That is the reason. Okay, then I need other value 2h0 by c is equal to 0.716. So all these values have been interpolated and I have been identified. Let me show you the again. See here, I need 2h0 value will be around 0.6 and 0.8. So 0.6 and 0.8, 0.716. And similarly you can see mu d by c 5.79 to 12.8. So I am having 9.87. And similarly go for 4q dc n dash by L, it should be available between 3.99 to 3.59. 3.99 to 3.59. I am having that 3.75. Okay, I hope you understood. And if there is any doubt in interpolation, I can make other video and I can provide it to you. Okay, so this is what very important for me, with which I need to find out all the unknown data. Let me take this first one. So mu is equal to d by c. Can anyone tell me what is a mu? What is mu? So mu is a common term which you have been already used in many of your notations. Can anyone tell me what is mu? Yes, coefficient of
friction.
yes, very good. So here I know mu d by c is equal to 9.81. So the d is nothing but diameter, c is nothing but a diametrical clearance. So from which I can write, let me take this as a 1. So here I can write 1 coefficient of friction, which is equal to, so 9.87 into 0.05 divided by what is the diameter value, which is nothing but 50. Okay, so if I simplify, I can identify what is the coefficient of friction, which is nothing but 9.87 into 10 to the power minus 3. So you kindly calculate it and try to identify this value, because calculating part is very, very important. Okay, so as per our question, what is the first one asked? I need to find out the coefficient of friction. Now I found out the coefficient of friction. Okay, let me take the second value. So the second value is nothing but a 4. Okay, let me come back to this as at the end. Let me come back to the next one, is a 2 h naught by c. I doesn't introduce about this h naught. H naught is nothing but a film thickness. So this is also asked in my question. The film thickness is also asked in my question. I know 2 h naught by c is equal to 0.716. I need h naught, which is nothing but the oil film thickness. I repeat again, oil film thickness. So that it can be written as 0.716 into, okay, into into 0.005 diametrical clearance, sorry, 0.05 divided by 2. Okay, so h naught is equal to 0.716 into diametrical clearance divided by 2. So if I calculate, can anyone tell me what is this value, sir? 0.716 into 0.05 divided by 2. Can anyone tell me the value which comes in millimeter? So if it is to be substituted in millimeter, you multiply it by 10 to the power minus 3, because this diametrical clearance value will be in meter, 0.05 meter. So if you want to have it as a
0.017.
yes, very good, 0.017. Okay, so this is the value h naught, which is nothing but oil film thickness. I hope you know that there will be some layer between two rotating parts. Okay, now I have found out the second unknown. Which is nothing but the minimum oil film thickness. Okay, so now I need to find out the next data. Okay, so and I forgot one data from our data book. Which is nothing but P C dash sigma T naught by P. I repeat again, P C dash sigma T naught divided by P. So where we need to find out the sigma T naught, which is nothing but the temperature rise. So which is nothing but the temperature rise. Okay, so temperature rise. So I'll add this value here. I can write, so P C dash sigma T naught divided by P. Okay, so this value, if I interpolate, I can have this value as a 40.43. Let me tell you how this value came here. See here, you come back to your data book. I need the value in between this S value, 0.264 and 0.631. If you come back to this column, the value would be available between 24.3 to 52.1. If I interpolate these two values, I can find out the value as P C dash sigma T naught divided by P is equal to nothing but the value would be the value would be around 40.43. okay. So I will take this again, okay. I am having the value of p let me take it as a rho c dash sigma t naught divided by p, which is equal to 40.43. okay, just a minute. okay, I doesn't know what is a p c dash at all. okay, so let us go back to our data book. You can see at the bottom, can you see here? I hope it is a rho c dash is equal to 14.2 into kilogram f centimeter cube. so 14.2 into kilogram f centimeter cube, but I need this particular value in a Newton per meter cube. So hence I need to convert this value. So I'll take this rho into c dash as given in our data book. 14.2 is the value given in our data book. You can see here rho into c dash is 14.2. To convert kilogram f into Newton, I need to multiply into 9.81 and divided by centimeter cube. I have to convert it into meter cube. So I will be having into 10 to the power 4 into 9.81. 9.81 is nothing but I need to convert a kilogram force into Newton. Sir, every data is available in your data book itself, sir. I don't know del T naught. I doesn't know what is del T naught, and I know what is the pressure, which is nothing but 1.3 into 10 to the power 6 Newton per meter square. So that is the reason why we are converting this centimeter square into Newton meter square. okay, so which is equal to 40.43. okay, so here the unknown value is nothing but a sigma t naught. So sigma t naught, if I substitute, if I replace the order and if I try to calculate the value, the sigma t naught value would be around 37.7 degrees centigrade. I request you to kindly verify it. okay, so which is nothing but the temperature rise. okay, as per our required data, we have identified the other data also, which is nothing but temperature rise. We already found out coefficient of friction. We have already found out what is the minimum oil film thickness. We have already found out what is the temperature rise. So now we need to find out what is the power lost, and what is the flow requirement. So this is what we need to find out. So power lost is nothing but if a heat is generated. So if a heat is generated, that is the power lost in case of a bearing. So what is the formula? From data book, you can write it from data book, page number 7.134. heat generated is nothing but mu into W into V. okay, so for V I can write V is equal to pi dn divided by 60, where we can substitute this value directly. I know the mu value, I know the load value. okay, so what is the mu value? We already find out, which is nothing but what is the mu value? 9.87 into 10 to the power 3. So you try to substitute. So 9.87 into 10 to the power minus 3. What is the load given is 3.2 kilonewton, which is nothing but 3200 Newton. okay, so into what is this value? Into pi into 50 into 1490, which is the n value, divided by 60. So I know all the values so that I can find out what is the power lost. Why I am saying this is a power lost? In the sense, whenever a heat is generated, definitely I am going to have some power loss. okay, if I substitute and if I try to find out the value would be around 123.2 watt. So kindly calculate it and you can verify these answers. okay, so now as per the requirement of our question, I have found out what is the power lost also. So the one and only unknown is flow requirement in liter per minute. So I have used this. The only thing I have not used is only this particular thing. okay, so I can write it over here, which is nothing but 4q divided by d c n dash l, okay, which is equal to as per our data book, which the value is 3.75. so q is nothing but what is the data we require, which is nothing but flow. Okay, Q is the flow what we required. So Q is equal to, I can write this, so 3.75. I have to write the diameter in terms of meter, which is 50 mm. I can write as 0.05 meter. The C value is again 0.05 into 10 to the power minus 3, since I need it in meter again, into what is the n value, 1490 divided by 60, because I have to substitute it in RPS. And what is L value, 50 mm. In meter it is nothing but 0.05 meter divided by 4. Okay, that's all. See here, 3.75 is this value, D is 0.05, C is 0.05 into 10 to the power minus 3, N dash is 1490 divided by 60 into 0.05 is the length divided by 4. If I directly substitute this value, you be very careful, all the unit will be of same value. See here, meter, revolution per second, meter. So everything, if I substitute in a direct value and if I identify, the value would be around 4.85 into 10 to the power 5 liter, so liter per minute. Okay, so this is what asked for me. Okay, now we have find out all the unknowns which is asked in our problem. Coefficient of friction, mu, power lost in friction, HD, minimum oil film thickness, H0, flow requirement in the liter, Q, and temperature rise, which is nothing but sigma T. So with which we have designed a hydrodynamic bearing. Okay.